Today we're going to talk about the phase diagram of water. Phase diagram can be used to explain a lot of changes, especially as it has to do with at what physical changes you have your matter. Remember that we had said that matter has different phases or phases it could change into, and most of these phases is a solid, liquid, and gas. To understand how these changes takes place, to understand how these phases move from one point to the other, you must understand the phase diagram. The phase diagram deals with two properties: temperature and pressure. And of course, you know that where there are changes in temperature, for example, if temperature is increased, okay, there's a tendency that you'll experience a change from a particular phase to the other. And when pressure is rather increased, you also expect to get some changes from another phase to the other. So today we are going to take water as a typical example. Remember that we also have a phase diagram for sulfur, where we have rhombic sulfur, where we have monoclinic sulfur, where we have alpha sulfur, changing from one form of the sulfur to the other. But here we talk about water. Water in room temperature is a liquid. We all know that. So you wonder why we say that water changes phase. Of course, water can exist as solid, liquid, and gas. So it exists as solid ice, it can exist as liquid, and also exist as what? Gas in terms of water vapor. So today we are going to see through a typical phase diagram how we can explain these changes from one phase to the other. Join me. Now, when we talk about phase diagram, the phase diagram of water, this is how it looks like. So this is a typical drawing of the phase diagram. At this point, we have a curve this way and have another one this way, and then we have another one this way. This is how a phase diagram for water looks like. And we're going to do some little labeling to bring us to the understanding of what we mean by changes in phases of water when there are influences in terms of temperature and pressure. Now, at this point, we have the triple point. The triple point. At this point A, we can label this as O and label this as B, label this as C. At this point here, we have the critical point. The critical point. You see, what happened in here is that the whole of this describes pressure, and the whole of this describes temperature. So where there are influences, increase or decrease in temperature, or increase or decrease in pressure, you begin to experience the changes that you see where water in liquid form changes to what? Gaseous state, or where the water in liquid form changes back to solid state. Those changes that you are seeing are as a result of what? Just influence on temperature and what? Pressure. Now, in this typical diagram that we have here, the whole of this area is described as your ice. That is a solid ice. And then the whole of this area is described as your liquid phase. And the whole of this area here is described as what? Your vapor phase. Did you see? That is a typical diagram for water, phase diagram of water. What plays around here? I want us to understand something. That these lines that you see here represent something very important. The line you see here is described as either your melting, or you can call it your freezing curve. Okay? And this line you see here, you can describe it as your vaporization curve. And this line here can be described as your sublimation curve. These are curves, and they describe the point at which these changes take place. But there is something very important we must know, and that thing is that at this your use of freezing or melting curve, there exists an equilibrium between the ice and liquid. There also exists an equilibrium at this point between your liquid and vapor, which is the gas. And there exists also an equilibrium between your vapor and also what? The ice. Something happened around this equilibrium. And what happened is this. At your melting or freezing curve, there is a tendency that the ice, which is the block, the solid, could change to what? Could cross this curve into this other area where you have the liquid. That means the ice is melting. So if the ice is melting, what has happened? What happened is simple. Is that at a point where you have the equilibrium, there is a possible change from either this phase of ice to liquid or liquid to ice, depending on your regulations of the temperature and pressure. So if the temperature appears to increase, what will happen is that the equilibrium will favor the liquid side. Therefore, the ice will do what? Start melting to form the liquid. It means that the temperature at which this ice has started melting is above what? 273 Kelvin or 0 degrees Celsius. The ice start doing what? Melting. But should you rather decrease your temperature and increase the pressure, that means pressure is above 1 atmospheric pressure. It is linking you to maybe 218 atmospheric pressure. At that point, what happens is that the liquid, the equilibrium favors what? The ice. So the liquid will start doing what? Will start going into blocks to form what? Start freezing to form what? The ice. You see? So when you increase pressure and reduce temperature, your liquid will do what? Start freezing into what? Ice. The equilibrium position does what? Shift to what? To the left. The same thing happens here. Once you choose to do what? Increase your temperature, you do what? You favor the vapor side. Therefore, the equilibrium here will do what? Shift, and then it is now going to cause a conversion of the liquid phase into vapor. So when you boil water, for example, you are gradually increasing the temperature of that water, moving it away from what? 373 Kelvin. And at that point, what happens is that the liquid will convert itself into what? Vapor. So there's a shift in equilibrium. The same thing will happen here, where you have O to B. So the sublimation is simple. It means that at any point in time where you have a shift in equilibrium to favor what? To favor the vapor phase, that means that you have done what? You have eventually increased your temperature such that the ice, you have increased it so much that the ice will escape going through the liquid phase. It will rather do what? Move straight to what? The vapor phase. That means the temperature has gone far beyond the normal temperature. So we said the temperature that will allow the equilibrium to favor the vapor phase instead of the ice phase is what? A critical temperature. And that is why at that point you could have a temperature of 374 Kelvin. That is a temperature that is about more than 100 degrees Celsius. At that point, you have forced the ice to do what? To convert itself from the solid phase directly to what? The gaseous phase. You have decided to shift the equilibrium to what? Favor what? The vapor phase. So everything that plays around the phase diagram of water, the changes, the physical states of matter changing in terms of water relies on what? What you do with the temperature and the pressure. But very interesting, so much interestingly, is that at this point we have here, we can describe this point also as what? Our boiling point of water. That means at this point to this point is 100 degrees Celsius, or what? Or 373 degrees Celsius. This is the point at which water boils. 100 or 373 degrees Celsius. And this is the triple point. The triple point simply means that at this point, both the ice, both the vapor and the liquid converge at this point to do what? To now distribute themselves into your different phases. So at the point where you are changing the temperature and pressure, everything is at the triple point. So depending on what temperature you are changing or pressure you are changing, you begin to see the curves moving and making those changes. And this at this point here is the critical point. The critical point is simply a point at which two phases appears to have properties that are indistinguishable. That means at the critical point where you have A here, you have a temperature that is above 100 degrees Celsius. You have a pressure that is above 1 atmospheric pressure. So the ice and liquid will be possessing properties that are indistinguishable at this point. You will not be able to understand if this is actually a solid or is what? A vapor, or is what? A liquid. Now, what we tend to achieve from the whole thing is that there are phase changes in everything you call matter, whether it's water, whether it's sulfur, whether it's oxygen, whether it is carbon dioxide. There are phase changes, and once there is a phase change, there must be an effect on temperature or pressure. So you today will not ordinarily be seeing water changing from liquid to vapor when you are boiling, or ice, melting into liquid. Your understanding today should be that if you put a piece of ice on a table and it's melting, it means you have provided a temperature to that ice such that it has done what? Shift the equilibrium to favor the vapor part. But if you want it to return to the ice, it means you have to do what? Reduce the temperature, increase the pressure, more than 1 atmospheric pressure, and more than the temperature should be also less than what? 100 degrees Celsius, to achieve the equilibrium shift from the vapor to what? To the solid ice, or from the liquid to the solid ice. So today's lecture, we have been able to establish the fact that temperature and pressure plays critical role in phase changes. So whenever you have anything at all, for example, you have ice cream and you see it melting, you should understand the fact that you have provided that ice cream with what? With a temperature that is higher than the ordinary, and have assisted the shift in equilibrium from what? The solid ice cream into what? The liquid that is also changing into, and also to gas, as the case may be. I hope today we've learned something very different from what we used to do, and something new as well. Do not forget to like, do not forget to share, do not forget also to follow. Until next time,